Example number 44. Solve the following logarithmic equation. Log 12y plus 5 to base 4 minus log 1 minus y to base 4 is equals to 2. So for you to solve a logarithmic equation, you must have the same base, isn't it? You must have the same? Yes. So this is base 4, this is base 4, meaning you must have base 4 for the other term. You must have the same base all through. Are we together there? So it means here we have log 12y plus 5 to base 4 minus log 1 minus y to base 4 is equals to 4. So you have to introduce log 4 to base 4. You must introduce a log of a number to the same base is 1, isn't it? Are you saying the log you are introducing? Yes. Log 4 to base 4, because a log of a number to the same base is 1. So if you have log a to base a, that is 1. So here base 4, base 4, base 4. So you have the same base. You can now solve it, isn't it? Are we together? So after doing that, you get rid of the coefficient. The coefficient becomes the power, isn't it? So here we have log 12y plus 5 to base 4 minus log 1 minus y to base 4 is equals to, now this coefficient 2 becomes the power, isn't it? So we have log 4 squared to base 4. Then the next step, you ensure the left hand side is one term and the right hand side is one term, isn't it? Meaning we remove log to base 4 outside, isn't it? We remove log to base 4. So if we remove log to base 4 outside, we will have here, we will remain with 12y plus 5. Subtraction changes to division, isn't it? Then 1 minus y. So if you take back the log inside division, we'll go back to subtraction the way it was, isn't it? That one is equals to log 4 squared is 16 to base 4. So once you've made this either side of the equation one term, you can now ignore the log on both sides. You don't come and say I have to divide by log to base 4. That is mathematically wrong. You ignore it. It's like you introduce log to base 4 on the other side of the equation, isn't it? You now ignore the log on either side of the equation. Are we together? It is a reverse process, isn't it? After ignoring the log, what do you remain with? You remain with the 12y plus 5 to be equals to 16 into 1 minus y, meaning you multiply both sides of the equation with the denominator, isn't it? The denominator is 1 plus y. We multiply both sides of the equation by 1 plus y because we've ignored the log on either side of the equation. After ignoring the log, we multiply both sides by 1 minus y. By 1 minus y. So that this goes with this. You remain with 12y plus 5 to be 16 times y and 1 minus y, isn't it? Are we together? Yes. Then you simplify, isn't it? Can you now simplify? Here you have 12y plus 5 is equals to 16 times 1. Then 16 times that, you get negative 16y. So negative 16y coming this side, it is positive 16y, isn't it? Plus 12, you get 28y. To be equals to positive 5, going the other side is minus, isn't it? 16 minus 5, 11, isn't it? So from there, you get y to be what? 11 over 28. You divide both sides by 28 to get y, isn't it? So y is 11 over 28 if you divide both sides by 28. Are we together? And you solve for y. Are we together? You solve for y.